Question 16 says a single slit of width 0.1 mm is illuminated by a parallel beam of light of wavelength 5000 angstrom and diffraction bands are observed on a screen 80 cm from the slit. The distance of the second dark line from the central bright line is, well, the four options are given. Obviously the question is based on diffraction by a single slit, and we know that when we are considering diffraction by a single slit, the position of nth minima is given by the expression A sin theta equals n lambda. A sin theta equals n lambda for nth minimum, right? A is the slit width, theta or sin theta, because the value of theta, if it is small, sin theta can be replaced by theta. So if we do that, we get A theta is equal to n lambda, and in this particular case the value of n is 2, so we have to substitute it as 2 lambda. So the angular position theta is 2 lambda by A, and if we want the distance from the central bright line, then that distance y can be given as d into theta, where capital D is the distance of the screen, the plane of screen from the slit, and which is given as 80 centimeter. If we just substitute the values, we find y is equal to 80 centimeter. Let's convert it to millimeter. So this will be into 10 millimeter, and then theta is 2 lambda by A. So 2 times the value of lambda is 5000 angstrom. So it is 5000 into 10 to the power minus 10 meter, and we divide it by A. A is 0.1 millimeter. So that means A is 10 to the power minus 4 meter. So this meter and this meter will cancel, and we will have answer finally in millimeter, which is the unit in which options are given. If we solve for it, we find the value of the distance y happens to be equal to 8 millimeter, which matches with option 4. Option 4 is correct. Let's go to the next question now. Question 17 says the maximum speed of the photoelectrons emitted by a surface is V0 when light of frequency F0 falls on the surface. If the frequency of the incident radiation is increased to 2F0, the maximum speed of the ejected photoelectrons will be, well, applying Einstein's famous equation of photoelectric effect, we can see that in the first case we have HF0 is equal to half mV0 square plus phi, where phi is the work function of the surface. And in the second case, when the frequency becomes 2F0, the energy of the photon is 2HF0, and that is equal to half mv square, where v is the maximum speed in the second case, plus phi. Using the two equations, we can see that phi plus half mv square is 2 times of phi plus half m v0 square. That means we have half mv square is equal to mv0 square plus phi, and so v is under root of 2v0 square plus 2 phi by m. Now it's very clear that this value is greater than under root of 2v0. Okay, v0 is outside the under root sign, and which means we have the answer now clearly. Option 3 is the answer. The speed will be more than root 2 V naught. It's not equal to root 2 V naught. It's not less than root 2 V naught. And obviously not option 1. So let's now go to the next question. Question 18 says the potential energy of a particle of mass m varies as ux is equal to E naught for 0 less than equal to x less than equal to 1 and is equal to 0 for x greater than 1. The de Broglie wavelength of the particle in the range 0 less than equal to x less than equal to 1 is lambda naught, and that in the range x greater than 1 is lambda. If the total energy of the particle is 3 naught, then value of lambda is. Okay, the concept of de Broglie wavelength is involved here, and we can see that if the de Broglie wavelength is lambda naught, that means the potential energy in that case is E naught. Okay, and if the total energy of the particle is given as 3 naught, and if we consider that the potential energy is E naught, then the kinetic energy is simply 2 E naught, and in that case the de Broglie wavelength is lambda naught. So that means we can write the kinetic energy 2 E naught is, of course, let's say half m V naught square, and where mv naught, the momentum, or we can call it P naught. We know that h by lambda is P is h by lambda, so that means this is equal to h by lambda naught. So if we make this substitution, we get 2 E naught is equal to h square by lambda naught square into 2 times mass of the particle. And if we consider that the value of potential energy is 0, so in that case the entire 3 E naught is the kinetic energy of the particle, and so 3 E naught is equal to h square divided by 2m into lambda square, again using the concept of de Broglie wavelength. So we have, let's call it equation 1, let's call it equation 2. We are interested in finding the value of lambda, so we divide equation 1 by equation 2, and if we divide equation 1 by equation 2, we get 2 by 3 is equal to lambda square by lambda naught square. That means value of lambda is lambda naught into root 2 by 3. If we multiply both numerator and denominator by root 2, this is lambda naught into 2 by root 6, which actually is matching with option 3. So option 3 is correct. Let's go to the next question now. Question 19 says the dimensional formula of magnetic permeability of vacuum mu naught, dimensions of mu naught is. Well, it's a question on the chapter units and measurement, where the topic dimension has been covered. So to get the dimensions of mu naught, we can consider equations of physics where mu naught is involved. So to get an expression where mu naught is involved, I consider the expression B is equal to mu naught Ni. Remember, this is the famous equation of magnetic field inside a solenoid. Mu naught Ni, N is the number of turns per unit length, I is the current, and there is mu naught, and there is magnetic field B also. I consider another equation where B is involved, and the magnetic force on a moving charge is given as Q into V cross B. That means purely in terms of dimensions, if we see, then F, dimensions of F is same as dimensions of QVB, and same goes earlier also, like dimensions of B is same as dimensions of mu naught Ni. Now to eliminate B on both sides, we can get this expression that F by mu naught Ni, dimensions of F by mu naught Ni will be same as dimensions of QV, which means dimensions of mu naught can be written as dimensions of F divided by Ni QV. Now let's put dimensions of various quantities. For force it is M L T minus 2, N is L minus 1 because it's number of turns per unit length, I is of course current, so let's put A for current, and charge is current into time, so it's A into T, and V is speed, so it's L T minus 1. So we can see that this and this cancel, this T and this T will also cancel. We have effectively now M L T minus 2 A minus 2. So this is, we are getting as the dimensions of mu naught, and if you look at the options, well, it's clearly matching with option 3. So option 3 is correct. Let's go to the next question now. Well, now we are at question 20, the last question of this segment, or this section rather, after which we will have the questions with numerical values. So question 20 says, a radioactive nuclei A with decay constant lambda decay into stable nuclei B. At t equal to 0, the number of nuclei of B is 0. At time t, the ratio of the number of B to that of A is 0.4, then T is given by. Okay, so it's given that at time t equal to 0, that means initially number of nuclei of B is 0. Let's assume that number of nuclei of A was N0, then Na at time t, Na at time t is simply N0 e to the power minus lambda t as per the equation of radioactivity, and Nb at time t will be the number of nuclei of A which have decayed. So that means it is equal to N0 minus Na, and which simplifies to N0 into 1 minus e to the power minus lambda t. Further, it is given that the ratio of Nb to Na is 0.4. That means this divided by this is 0.4. Okay, so Nb upon Na is 0.4, and that is also equal to 1 minus e to the power minus lambda t divided by e to the power minus lambda t. On simplifying, we will find that 1 is equal to 1.4 into e to the power minus lambda t, which means we have e to the power lambda t as 1.4. Taking natural log on both sides, we get lambda t is equal to ln 1.4, and which means t is equal to ln 1.4 divided by lambda, and which clearly matches with option 4. So option 4 is correct. Let's go to the next question now.